Before I get started, a couple of interesting quotes that came out at the end of last year from Gartner, all about making sure that you're doing proper planning to ensure that your Wi-Fi network is capable of supporting the devices that you're going to be deploying. This one was really surprised that they came out to say that without proper planning, you're going to need 300% more Wi-Fi, or 3 times the coverage. And we'll get into why that is here in just a little bit. The other thing they talked about, and this was kind of scary when I first saw this, 80% of the networks that are being designed today aren't going to support the devices in the future. So that's another thing, as IT professionals, putting an infrastructure that gives you long-term growth and the ability to migrate or scale to support new standards and to support higher capacity devices is very critical. I'm going to skip through a couple of these slides here. One, and Christian showed this slide of the evolution of Wi-Fi. Wi-Fi has been around since 1999. Anybody deploy Wi-Fi in the early 2000s, right on the bleeding edge, where BG was the predominant device? Things have changed quite a bit since then. In the last few years, there's really a hockey stick of standards and capacity enhancements that are happening within Wi-Fi. What's pushing this? It's all of these new devices. The iPad, it really changed everything. The iPhone, and more folks want to use these devices within the enterprise. So IT professionals are struggling with how do I support them? How do I give that user the same amount of bandwidth and the experience that they have at home when they have a 6 meg cable modem or DSL? How do I give them the same coverage that they get within their home? So there definitely are some struggles. As TIG mentioned, proper assessment and proper planning really will help you, look around the corner and prevent these dissatisfied users. When they come into the enterprise, they say, why is my iPad so slow compared to when I have it at the home? AC was announced last week at CES. This is a new Wi-Fi standard. The first iteration of AC products are going to start showing up here in the next 6 months. Typically, as in Wi-Fi, you'll find, and this happened in 802.11n as well, consumer products get these standards pre-ratification first, then you start seeing them show up in the enterprise solutions. Expect to start seeing AC products by the end of 2012, if not early 2013. What AC gives us is higher capacity, better range, and more streams of data simultaneously. So I can send more data at the same time. The first iteration of AC will allow you to support 1.3 gigabits, and the standard calls for up to 7 gigabits of throughput. And as Christian mentioned, 2.4, our legacy BG products are not part of the program. They're not part of that standard. And the reason being, and when Christian showed the lanes in the freeway, 2.4 has 3 non-overlapping channels, 1, 6, and 11. Those that have been deploying Wi-Fi for a while know how difficult it is to get those frequencies to not overlap. You tend to turn down the radios, or in many cases, with a traditional Wi-Fi AP, you're turning off radios. The newer radios that are out, make sure that you're looking at vendors that give you multi-state radios. That is a radio that allows you to support the legacy devices today, the 2.4 devices, the BG networks, the iPhones, for example. The iPhone happens to support BGN, so it allows you to support the 2.4 gigahertz version of that protocol. But make sure that your networks allow you to switch from 2.4 to 5 gigahertz. For some reason, most of the vendors out there, when you buy an AP, it's one 2.4 gig radio and one 5 gigahertz radio. That would be great if 50% of the capacity or the channels were available on 2.4. Unfortunately, only 1/8 of the amount of spectrum, 3 versus 24 channels, is available on 2.4. So keep that in mind as you're looking at new devices, you're rolling out new Ultrabooks and new laptops and so forth. Make sure that they support the dual band, or both 2.4 and 5 gigahertz. And then you'll be backwards compatible to these new standards that are coming out. You know, Christian talked about yesterday's approach and today's approach. Just a couple other comments on this I wanted to talk about. With today's approach, instead of having to rip and replace or adding more APs to increase your capacity, the ability to take a chassis, okay, this particular chassis is our mid-size chassis. We support 2 radios, 4, 8, or up to 16 radios per access point. And if I want to increase capacity, I just add a radio card, pop that in, and now I've just, in this particular system, I've just added 450 megabits of additional capacity. Each one of these radios are modular, and they're using a standard bus, a PCI Express bus, which is the same format that wireless cards interface to your laptops. This allows me to quickly add in new radio standards as they evolve. Some of these radio standards we may not even thought of, or even the IEEE hasn't come out with, that are around the corner, 2 or 3 years, maybe a little bit more. So the ability to have a modular system, just like some of the Cisco chassis, allow you to add boards, upgrade from 100 base T to gig to 10 gig. The same approach really needs to be considered in Wi-Fi. Otherwise, you end up with a lot of ripping and replacing or adding additional APs. And anybody that's expanded their Wi-Fi network very quickly, you find that just by adding up, throwing up more APs doesn't solve the problem. In many cases, we can go into a network and say, remove a quarter of these APs and you increase your capacity, especially when you get into situations where you're interfering with one another, you're conflicting. The other nice thing with 5 gig is you're not going to have to worry about being interfered with these other 2.4 gigahertz technologies. Most common is Bluetooth. All your Bluetooth devices that you have are using 2.4 gigahertz frequency hopping, so they're interfering with all channels, as well as the MiFi devices. I saw a couple of you have iPhones set up in access point mode, so you can connect your iPad to your iPhone to get out to the internet. These things are also interfering sources. Most of these are on 2.4 gigahertz. Okay, so I'm going to set this back down. And you guys can pass this around and see how easy it is. Just like adding memory to a laptop, I just take this card and plug it right in and increase it. We'll be able to do the same thing once the Broadcom and Xirrus and the other chip manufacturers start shipping the approved standards of 802.11ac, which again is expected at the end of this year or beginning next. I'll pass that around. Okay, let's see. Get my clicker. This is a traditional approach. Many of you have seen this. This may be your floor plan itself. You started out with a few APs. You added more devices. You had to bring in more APs. You're running more cables. You're adding more switch ports. The switch port manufacturers love you because you have to keep adding more ports. Our approach is quite a bit different. You add arrays, a smaller number of arrays, because each of these arrays allows you to support 2, 4, 8, or 16 radios. So again, instead of running cables, adding switch ports, I'm adding radio cards into the chassis to increase my capacity. Much easier to manage a small number of devices than a large number of devices like this. So not that any of you have ample time sitting around just wanting to manage more devices. This will certainly reduce that burden for you. We talked about a lot of those. This is just a slide of the 4 main products that are available. Like many of our competitors that have traditional APs, we have a 2 radio product. It's much smaller, similar in size to some of the other ones that you've seen. We have a 4 a product that is becoming our most popular. It starts with 2 radios, and I could double the capacity by adding 2 of those same radio cards. The radio cards are the same across the entire product family. So I can start with a 2 radio, and as I increase the number of devices, or as my application requirements increase, I'm running high resolution video and things like that, you pop in a couple of radio cards, now you just doubled your capacity. That's the 2000 family. The 4000 starts with 4 and can be upgraded to 8, and then the 6000 series allows you to start with 8 and it can be expanded to 16. Those are typically used in very high density environments, like for example, this past week we just won the Moscone Center up in San Francisco. Good news for the Apple folks, Tim Cook and some of his upcoming keynote addresses are going to have the issues that we had a few years back when the Wi-Fi, Steve Jobs had to tell everybody to turn off their Wi-Fi devices because they weren't able to connect to the network. So they're going to have high capacity solutions there. So that's the 6000. Again, it's a small percentage of our sales, but for those high density cafeterias, auditoriums, things like that, very useful. That's what most of the competitors look like. They've got a centralized controller, which tends to be your bottleneck in the network. As you add additional access points, you typically have to add or beef up, add additional controllers to be able to support the capacity. Often we go into networks and either the controller is over-provisioned, where they bought the high-end controller and they don't have enough APs, so they probably spend a little too much money on that, but more often it's under-provisioned. Also, you'll see many of the controller-based solutions, when you turn on WPA2, which is the most common enterprise method of encryption, your total throughput through that controller drops dramatically. And a couple of the top 2 vendors, it's as much as 25 or 30% of the capacity drops because the encryption is done at the core of the network. Every one of our access points has a distributed controller, so there's no single point of failure. And that also, much like those that were doing IT back when we had routers and hubs, raise your hands. Probably a few of you out there. Now we're core switching. Similar architecture change in our solution. Instead of a bunch of low-powered access points being tunneled back to a centralized controller like a router, each one of our arrays have a distributed switching and controllers right at the edge. So a big fundamental difference in the design there. So this is kind of a summary of the architectural advantages. The key is looking at solutions that provide you upgradability or modularity, plus the ability to evolve as the standards evolve. There's a standard-based bus to allow us to add not only new Wi-Fi standards, but there are a number of vendors out there that are trying to combine 3G, 4G, cellular type standards into a similar platform. So as those radio cards become available, there's standard buses. We can click in a 4G radio card or a 3G radio card to allow you to have better signal within the enterprise on your cell phones, for example. The distributing, the processing at the edge, no single point of failure, those are all key differences. The other is make sure that your platform supports multi-state. So the ability to start with 2.4, or some percentage of your devices are 2.4 today, and as those legacy devices go away from the network, you can, by software, pushing from the center of your network, change those radios within seconds to 5 gigahertz, now just increase the capacity. Yes, go ahead.
Is that still centralized management?
It is centralized management. I've got a slide here on centralized management because the key reason that controllers were developed, there were 2 key reasons in the early 2000s. One was security. Okay? In the early days, we had web. We had to come up with a centralized way of managing these devices and securing those devices. So a centralized controller was a great way of solving that problem. And back then, we had 11 megabit and 54 megabit radios. So tunneling all that traffic from all those devices to the core of the network was fine. Now we've got 300, 450 meg radios we're shipping, and very soon, 1.3 gig up to 7 gig. Tunneling all that traffic to the center of the network is now a bottleneck. So what we've done is we've created a distributed model for managing your devices. They can be managed from the cloud, run as a VM application or virtual application, or they can be managed at a Windows server or Linux server at your site. And all of the devices, whether they're at your location or they're at other branch offices or other locations in the world, can be managed from a central location because we use standards-based secure SNMP to manage, monitor, and do reporting for each of those devices. And XMS acts as a central SQL database to collect all that data and allow you to do your reporting based on that information. Any other questions on centralized? I mean, it's key to be able to centrally manage, to make it very easy to deploy as you add additional arrays, to be able to do that without having to log into that device and push a configuration down. You want to be able to plug the device into the network, have it phone home to the XMS server. The XMS server will push its policies and its profiles down to that device so that you don't have to individually configure it. Now you can go in there and change guest access privileges or other functions within that device. The other key feature of XMS is the ability to do what's called device fingerprinting. You're going to hear more and more vendors talk about device fingerprinting, and that is the ability to, based on the type of device, is it an Android, is it an iPhone, is it an iPad, put them in their own network with certain privileges that they're able to gain access to certain assets on your network, right? So you can do that. I can tell you how many iPhone 4Ss, how many iPhone 3GSs, what operating system they're running. All of that information is passed over the Wi-Fi protocol. We collect that information. We allow you to put them in a group and then give them certain profiles or certain privileges to resources within the network. As these devices change, as we have Wi-Fi watches and other Wi-Fi enabled devices that are out there, you're going to find you want to give them certain privileges compared to the enterprise tools. So that's it on Xirrus, the array architecture, the ability to manage these devices from a central location. I know we're going to get all the folks, presenters back up here and have a Q&A session. Works out.
Thank you, Rick. Maybe the best thing is to turn that mic off. Yeah, the other one up here? The other one. So we'll just pass this and just ask that everyone speak loudly when you ask your questions, because it's great learning for everybody to hear your questions so that the answer can apply to everybody.